All right, ladies and gentlemen, let's do one of the very important videos that is going to get you ready for algebra, and that is 9-2 functions. So a relationship that assigns exactly one output value for each input value is called a function. Functions are often written as equations, okay? So a lot of times, right now you're going to see it as this f of x. That's reading as the function of x, and then there usually be a value in there for x, and that tells you what to plug in. But the outcome here becomes your output. A lot of times, too, in algebra, you're going to see this as y equals 15x. So kind of keep that in mind that these are very similar input-output. So that's some vocabulary for you. So to find the value of a function for a certain number, we're just substituting in the value of x that we're given here. I like this because it's just like a plug in, get out. So it says the function of x when x is 9, if this is the function. So I'm going to go and I'm going to place the value that they want in there. So they're saying if x is 9, then I'm going to replace it with 9. And so I write the function when x is 9, and I get 4. That's it. So I just substitute it in and go. Down here, same thing. So I'm going to just write it out first. The function of x, 2x plus 1. And then we want to find out the function of x if x is negative 3. What would I get out for y? So I have 2 times negative 3 plus 1. Using order of operations, I do my multiplication first. So I find out that the function when x is negative 3 is negative 5. So just knowing that simple information, I know you can kind of see it through there. It's transparent the way I used to do it on the smartboard. Ignore it and try to do it on your own. Or maybe you could just pause it like this, so then you're not tempted to see the answer first. So maybe if that's what you're going to do, pause now. Otherwise, here I go. So we're looking for the function value, the output, when we know the value of x for function of x is x minus 4, when the value of x is 2. So we plug in or substitute in the value since they're the same, and I find out that the function is negative 2. Over here, we're looking for the function, the output when x has a value of 6. So I replace x with 6. I substitute that in. I get the function 12 minus 8, so the function of x is 4. Not so bad, I hope. It's just plugging in. It's kind of like what we've done in 6th grade and 7th grade when we just plug in and we substitute in when we're just given an expression, essentially. So this can be shown in a table. A table shows an input and output, and it shows your domain, which are your values of input. Later on, you'll learn that those are your x values. And your output is going to be your range, and this can be organized into a function table. So we complete the table for the function of x if x plus 5, and then we'll state the domain and range, and I'll show you how to do that. So what you do in the table is plug that value in for x and get your output. Plug that value in for x and get your output each time. So you'll see, notice you're kind of making a pattern here, just like we did with our algebraic expressions. This is what the table should look like there, and I guess I should have written that in. Oops. And so what we're going to be asked to do here is fill in our domain and our range. So remembering our domain is our input values, our x values, and how we write that is we use these little bracket thingies, look like a squiggly, and you list those numbers that you input. I plugged in negative 2, negative 1, 0, and 1. Your output values, your f of x values, or y later on, your range, those output values of 3, 4, 5, and 6. That's it. This will all come together eventually, which you feel so good about. So copy and complete each function table and then state the domain, the domain and the range of each function. So I plug in each value of x, and you might have to do some adding of the opposite. And I like to show that so you can see what my thinking is. Okay, so I noticed that my domain, my inputs for domain, squiggles were -3, -2, -1, 0. Those are the values I put in, and the values I got out in this function were -10, -9, -8, -7. Here I'm doing 4 times the number, 4 times the number, 4 times the number. So right now I'm just going to plug those in. That's 2, not a -2. And see what my outputs are. Positive times a negative is a negative. Positive times a positive is a positive. So my domain, my input values, were -5, -3, 2, and 5. My range values were -20, my outputs, -12, 8, and +20. One more to go. Plugging in this one, notice you're going to have to do a little bit, 2 steps. So we have 2 times the value of x plus, it's supposed to be a -1, plus 3. So I'd have a -2 plus 3, which would be +1. 2 times +2 plus 3, so 4 plus 3 is 7. 2 times a +3 is 6, plus 3 is 9. 2 times a +5 is 10, plus 3 is 13. So my domain, my input was -1, 2, 3, and 5. My range, my output was 1, 7, 9, and 13. So sometimes they're written using 2 variables. One variable represents x, and the other one, like we talked about, usually represents y, which again is your output, that f of x output. So like this has actual meaning, it's not just numbers. A lot of times when you do something, it has, every time you do something, it has an effect, and there's a change, right? So like if I go to the store, like I said in the last video, and I buy shirts, well, if the shirt costs $7, if I buy 1, my total cost is 7. If I buy 2, which is a different input, my total cost is 14, different output. So you'll see that. So maybe this word problem won't relate to you as much, but kind of be thinking about things that do, that you change a certain value and your output also changes. So functions with 2 variables. A veterinary technician needs to administer medication to a dog. The dosage is 5 milligrams of medication for every 1 pound. We want to write a function to represent the amount of medication needed for p pound dog's weight. And then we'll determine how much medication we need to give a dog that weighs 33. So what I notice is that we're trying to figure out the amount of medication. So when you do an equation, you always have a total that we're looking for, and then how we reach that total. So we're thinking what we're looking for is m, the amount of medication. Maybe I'll put that in blue since it's blue over here. And that medication, the amount we need is, right, it's equal to, see, is the dosage that represents is, I'll put this in green, 5 milligrams, it's 5 times for every 1 pound. So for every 1 pound, the number of pounds that the dog is. So that's kind of just how I worked my way through that. 5 for every 1, so it's 5, meaning increasing 5 every 1 pound. So if you picture that in a table, if a dog weighs 1 pound, it's 5. 2 pounds, it's 10. 3 pounds, it's 15, and so on and so forth. So if we want to figure out that for a 33-pound dog, which represents P, our output is going to depend on that input of pounds. And what I find out is then that the medication is 165 milligrams. So those are a little tricky, but you can do it. Don't sell yourself short. So one more again, kind of see through. So pause here if you're willing and able, and I think you are, to just give this one a go for home repair. So an air conditioner repair service charges $60 for a service call plus $30 per hour for labor. Write a function to represent the charge C for the service call with H hours of labor. How much would the charge be if there were 3 hours of labor? This question here tells me what my variables are the statement, and then this also tells me what I'm given is 3 hours, and then I'm looking for the charge. Okay, so I'm going to use some variables to represent some things. So I have H, which is hours of labor. C is the total charge or total cost of the service. So what I'm looking for is the total cost. How I reach my total is equal sign that I notice that we're charging 60 no matter what plus $30 per hour. So what that looks like is that I'm paying 60 plus $30 for every 1 hour worked. Generally, I would write this variable first. So I would write it $30 for every hour plus the 60 no matter what. So if I'm being charged and it's 3 hours of labor, so I take that and I plug that in. So the cost at 60, it's $30 for 3 hours of work. So the cost would be that $60 plus that $90 for work. So the cost is $150. So it's going to cost $150 to get the air conditioner repaired. All right, ladies and gentlemen, this will all be tied in, and you're going to use these so much in 8th grade algebra, so make sure that you try to understand just like the relationship between input and output, and you do it in your daily life, especially when you're shopping or you're buying multiples of things, or even amount of time I spent studying and the outcome of my grade. You deal with this all the time, so just really try to think beyond the numbers, and you should be great.